Hi, everybody. My name is Justyna Osowska, and I'm the founder of Women in Blockchain Canada. Today, I'm here joined by a special guest, Jordan Lass, who is the co-founder of Demergent Labs. How are you today?
Hello, I'm good. Thank you.
And what we'll be going through today is actually him helping you guys get set up on the Internet Computer Protocol. I'm sure he'll get into all the technicalities of that. But it's really important because for those who may already know TypeScript, this is a great gateway to get involved in blockchain and as well get a deeper knowledge using what he has already built to learn about it and start deploying smart contracts on the Internet Computer Protocol. So I'll let you take it away.
Okay, awesome. Yep. So, like Justyna was saying, I'm Jordan Last. My company is called Demergent Labs. We are working in the Internet Computer Protocol space or area. And just to give a quick introduction to the Internet Computer Protocol, um, it is similar in some ways to other blockchain computers, but in my opinion, I think it's best described as a uh, progressively decentralizing cloud, essentially. So it's a general purpose computational environment. It is not limited strictly to financial applications. It is, it kind of goes above and beyond many of the other blockchains in the general purpose nature of what it's trying to do. You don't have, kilobytes of RAM available. You have gigabytes of RAM available. You don't have It doesn't cost necessarily millions of dollars to store a gigabyte of data. It costs a few dollars a year to store a gigabyte of data. This is really orders of magnitude more computational uh, resource available to you. Now, it does take some trade-offs to get there, but just to give you that intro. And I'll share my screen now. I need permissions.
Mm-hmm. Go ahead. Should work now.
Okay, cool. There we go. Yeah, so like I said, the Internet Computer is a general purpose cloud, decentralized cloud. And today, what we're going to dive into is a project called Azel that my company has been uh, has been working on. Azel is what we call a canister development kit. You can also think of it as a regular software development kit. It lets you develop internet computer applications in TypeScript and JavaScript. So, an internet computer application, we call them canisters. It's roughly equivalent to a smart contract on your smart contract blockchains like Ethereum. It is, yeah, I mean, it's the encapsulation of your code and your state deployed to the internet computer. Now, just to give you, if you want to just dive in on your own, the two main resources for getting started with TypeScript on the internet computer would be the Azel book, which you can find here at demergentlabs.github.io/Azel, and then the Azel GitHub repository, which basically has a link to the documentation, a link to the Discord channel, and has the actual code. If you're interested in that, you can open up issues, etc. Um, just to give a quick disclaimer on things, Azel is a beta project. It may have some unknown security vulnerabilities, basically to the fact that it's new, but it's relatively full featured compared to the other CDKs on the internet computer, and you can definitely get started prototyping. And it might be fine for some production use cases. You just would need to make that determination for yourself. So, with all that said, basically, let's get going. The Azel book, FYI, is designed as a guide. So you should be able to basically go through chapter by chapter, and it's going to build up a concept by concept to help you understand the programming on the internet computer, focused, of course, on TypeScript. So chapter 1 and 2 just gives you a general introduction of everything. Wait, let me go back to chapter 2. Chapter 2 is really nice, in my opinion, because we go pretty deep into the benefits and drawbacks, not only of using Azel, but of the internet computer itself. It's not like the internet computer is, 1,000 times better than anything else out there in every single case. It chooses a certain set of trade-offs, and those trade-offs have certain benefits, of course, which you can go and read here. And obviously, there are some drawbacks as well. So if you're interested in all that, I spent a good amount of time getting my thoughts out on that. So please check out chapter 2. But here you go. You decide that you want to build something on a computer. You want a decentralized cloud application. It starts off with 2 simple dependencies. The first is Node.js. You probably already have Node.js installed if you are a web developer. If it is your first time, or even if you do have Node installed, I really highly recommend using NVM, the Node version manager, to install Node. And we are on version 18 for right now. This is the latest long-term, the LTS version. So please just follow the exact versions in here if you want to avoid problems. If you know what you're doing, you can maybe go off your own path, but generally keeping with the specific versions in here will be the best way forward. And then here's something probably new to you. It's called DFX. These are the Dfinity. Basically, it's a Dfinity command line interface. You install it with a simple command here in your terminal. So I've already installed it, but to show you how that would work, just run it, and it's going to download itself and get installed. And that's basically it. Node.js and DFX, which brings us to chapter 4, the hello world. There is a quick start right here. If you just want to get started ASAP and don't really want to get into all the technical details, basically just run these commands one after the other. And at the end of it, hopefully you will just have a locally deployed internet computer application. But in this video, we're going to skip the quick start and do the methodical start and show you step by step exactly what's going on here under the hood. And hopefully you'll notice it is not that different than any normal Node.js application. So, all right, we've installed DFX. That means we have this new command, DFX, with all these options. You should be working with DFX version 0.14.2, and we are, which is great. So first step, as it says, we're just going to make a directory for our project, and we're going to change directories into that directory. So I keep my projects in a folder called development and this folder called test. You can store this directory basically wherever you want. Just put it somewhere somewhere nice, I guess, somewhere that you want. All right, we've made our directory. We're going to head into that directory. So I've just called it Azel Hello World. It's completely empty. There's nothing in here. It's not. There's no magic. Highly recommend using Visual Studio. This is our text editor. If you're a web developer, you probably already use this. If you're entirely new, just download it and start using it is my recommendation. So I've opened up my project here. Again, it's completely empty. We have not done anything yet. Now we're going to make a directory called source. Okay, nothing crazy, just source directory. And then we're going to make 3 files. The first will be our index.ts file. That'll be inside of our source directory. That is going to be the entry point to our application. We're going to make a tsconfig file, which if you're a TypeScript developer, you are definitely already familiar with that. And then a new file, because this is the internet computer, it is called dfx.json. It's a config file similar to tsconfig or the package.json. And then we are going to install Azel. It is an npm package. And installing Azel is going to give us our package.json file and our package lock.json file. Okay, so we've got all our files here. Node modules is here as well. Like I said, nothing new here. Our package.json is very simple. It just has ASL in it. Package lock, you should be familiar with that. And our dfx.json is new. So obviously this is a completely empty project. There's nothing in it yet. So let's start filling it in. For now, we're just going to copy paste, and then I'll come back and explain exactly what's happening. But this code is your canister. So it is a very simple database, basically, where your database is just one string. And I'll dive into that in a second. Just copy the tsconfig.json file over. These are the recommended settings. And then our dfx.json, you should also be able to just copy that over. The tsconfig, I won't really go through that. It's, just a bunch of settings to get this to work. But the dfx.json, let's go into that a little bit. So, like I said, applications on the internet computer are called canisters. And in your dfx.json, you're basically going to provide a bunch of metadata about each of your canisters. In this case, we have one application, one canister called ASL Hello World. It's a custom type. There are other types on the internet computer, Rust and Motoko. Rust is, of course, the famous systems programming language, one of the best languages ever, in my opinion, but also very complicated, very steep learning curve, very, very engineering focused. And then Motoko is another language that the Dfinity Foundation created for the internet computer. In our case, we are using TypeScript and ASL. So for now, we have to put in some of these custom commands. The build command will actually basically compile all of your code and deploy and help in the deployment process. These things, you basically just copy paste them. This is your candid file, which we will get into as well in a second. And then finally, the path to your WASM binary. This will be generated for you automatically. One thing to understand is that the internet computer is a WASM environment at its core. There's a WASM runtime. So everything in the end needs to either be compiled to WASM or to run on top of WASM. And that's what ASL does. It embeds a JavaScript interpreter that is compiled into WASM. And that should be it. We've got all of our config files. And finally, we have the actual application code. So let's just get this thing deployed. We're going to use the dfx start command. What that's going to do is it's going to boot up an internet computer replica, basically a node. Your computer is going to become a node. And it's running the internet computer protocol locally just on your machine. So it's basically a local test environment. Okay, so that's up and running. And then we use the famous, it will become famous to you, dfx deploy command. dfx deploy, go ahead.
Sorry to interrupt, but I guess for those listening, that means that basically in order for you to test things on the environment, you don't need to spend any money, right? But then if they wanted to check more opportunities with the Dfinity Foundation, they can find that on the website. If they did want to go and pursue something more. And I think also Jordan, yourself, and the ICP North America Hub are going to be offering different things this year for people to get advanced within the ecosystem, from my understanding.
Yep, exactly. So first, what you were saying was about the local environment. Yep, if you just dfx start is going to build up, like I said, a local replica for you. You don't need to purchase any ICP tokens. You don't need, you don't need anything to get started locally. When you do want to deploy to production, Chapter 5 goes into that in more detail. Chapter 5 explains a little bit more about local development. And then basically, if you want to deploy to the actual internet computer, the command is almost the same. You just add -- network IC, but you need to get yourself set up with something called cycles. Cycles are the computational unit basically a measure of computation on the internet computer, and they are an actual payment mechanism to actually pay for all of the computation that's happening. There's official documentation that explains how you can get a Cycle wallet and make sure that you have all this set up. So when you're ready for production, I recommend going to Definity's documentation. The ASIL book is hopefully everything besides deploying to production. The idea is that it's local and in production should be very, very similar. Obviously, there will be differences. So, and then yes, there are some other resources which I guess we can explain later, and we'll put links in. But there's a course out right now on Decod, the Decentralized Academy. It's called like TypeScript Smart Contract 101. You can take that right now. And Code and State is doing an ASIL bootcamp that we will be participating in at the end of August. And we're thinking of having an in-person portion of that in Texas as well. So we'll make sure that you have links to all that.
Where in Texas?
In the Dallas-Fort Worth area.
Okay, perfect. That's good to know.
Yep. Okay, so if we go back to what we were doing, let's see what we were doing. We were deploying. So, all right, we successfully deployed our application. So let's just dive into this code real quick, and then we'll play with it. So first off, a lot of the functionality that you need on the internet computer. First off, just notice this is just TypeScript basically, right? There's nothing too crazy here. Yes, we have these annotations that are a little bit custom, but everything else here, that's just a normal return type. These are normal parameters. You're returning void, you're exporting functions, you're importing things from ASIL. You have a global variable. There's nothing too crazy here. Now, the internet computer specific functionality, a lot of that is going to come from the ASIL library. So that's why, that's what this query and update. That's what these imports are for. The query import in particular allows you to mark a function as what we call a query method. Query methods are read-only methods. They do not go through blockchain consensus. Remember, these blockchains and these decentralized computers, oftentimes their main purpose is to provide a fault-tolerant environment, a Byzantine fault-tolerant environment, where it's extremely. The point is that it shouldn't matter who is running these hardware on the network, and it shouldn't matter if nodes are dropping out or malicious up to certain bounds. Your application is going to be safe. So query methods, they don't have that Byzantine fault tolerance right now. They're just read-only. They execute very quickly, on the order of tens or hundreds of milliseconds. And generally speaking, if you want to just read something, that's what you're going to want to go for. So we've got our little message global variable here, and we have our get message query method. And what's going to do, it's just going to return whatever the message is. So I can actually show you what that looks like right now. On the command line, you can call your canister like this, dfx canister call. You put in the name of your canister, and then you put in the name of the method that you want to call. Our method is get message. Okay, and it returned an empty string. That's because there is nothing in here yet. It's just empty. Which brings us to our second import here, update. This annotation will mark a function as an update function. Update functions, when you call them, they do go through the Byzantine fault-tolerant consensus mechanism. They will take a couple seconds to complete because basically all the nodes that are running this canister are trying to agree that the state change, in this case, updating the message variable, that state change is valid. So notice we're going to receive a new message as an argument, and we just set this global variable. And that's it. This is something called orthogonal persistence. Anything stored globally which is going to be under the hood stored on the heap, is automatically persisted across update calls. So if you want to, if you have a simple enough application, you can just use global variables as your database and just write into them, and they're going to be automatically persisted. The internet computer basically allows your canisters to run forever as eternal processes, um, which is really cool. And there's some caveats and a lot to get into on that, but that is the general basic idea. So let's try to call this method from the command line. I'm going to call set message. In this case, we need to provide one parameter. Hello world. So we're going to call this. Notice it's going to take just a little bit. And now if we call the get message method, it returns hello world instead of the empty string. One more thing, if you're not into the command line, there is a browser interface. It's more of a GUI, so I can just call things here. And I'll change this to something else. Call, just takes a couple seconds. And then I can query again and just change something else. So you can interact with the canister from the command line, or you can interact with the canister from this nice browser UI. And that's it for the most basic tutorial. This is how you set up an internet computer project locally in TypeScript. This is how you boot up a local replica and deploy a canister into that replica. So we can pause there. Is there any
I think maybe the last thing is maybe what do you think people should know about what you're going to be teaching at the end of August and what the expectations are regarding the event that you would be hosting?
Yeah, so it's basically the Web3 or TypeScript with Web3 bootcamp. We do expect you to be somewhat familiar with TypeScript. So we're not going to be teaching TypeScript or JavaScript from the ground up. So if you're a complete beginner to web development, I mean, you could definitely join, but it might be difficult for you. But you do not need to know anything about the internet computer. You don't need to know about blockchain. And the week will be focused on building DAOs, so decentralized autonomous organizations. We're going to dive into the internet computer features that essentially allow us to build these decentralized organizations.
Excellent. And so that's the in-person event you're talking about, but they can also join online or
Yeah, so the bootcamp is mostly virtual. Like, if you want to do it, you can definitely do it virtually. We are considering an in-person event. We will need to confirm that that's going to be the case, but it's looking like we will probably be doing that the 28th, 29th, and 30th of August. Of course, I'll give you all the details to officially put into the links. So worst case, the event goes from the 28th. Oh, wait, sorry. I might be getting these dates wrong. It might be I think it's the 21st to the 27th. We'll give you all the correct dates. It's at the end of August. The in-person event, if we do it, will be just a few days, but the virtual event is the entire week. We're going to have office hours the whole week. Yeah, basically, we'll give you the links and you can dig into all that.
and what would be the purpose of the in-person event then? Is it like something, a continuation of what they've learned during the boot camp?
Yeah, it's just if you want to have access to the Demergent Labs team, all three of us, if we do the event, will be there, and you'll be able to also be in person with other people. There probably won't be too many. I mean, we're expecting a handful of people, maybe 5 to 10. The Motoko Bootcamp has done this before. I think in their second bootcamp, they had like 20 people. It was just apparently like a really good experience for them to be in person. So it's not something crazy and huge, but if you do, want to get together with some like-minded people, then we're thinking of offering that.
Excellent. Thanks so much. And I look forward to hosting more of these with you so people get the exposure to what can be done on ICP.
Yes, you're welcome.
Okay, great. Let me just stop the recording.